Hello students, I'm Mr. Troxel and welcome to 6th grade math.
On today's video, we're going to be talking about integers. We're going to identify integers, we're going to order integers from least to greatest, we're going to learn to add integers, we're going to learn to subtract integers, we're going to learn to multiply and divide integers, we're going to learn about the absolute value of integers, and we're going to take a shot at a temperature difference word problem using integers. Let's get started. What is an integer? Well, an integer is a whole number, negative or positive. So when we look at the numbers below, we're only looking for numbers that are whole numbers, that aren't a portion of something, that aren't a fraction of something, that aren't a decimal of something. The number has to be whole. So let's start with the first one, 14. Is 14 an integer? What do you think? Well, is it a whole number? It is 14 of something. Is it a decimal or a fraction? It's not. It's a whole number. So 14, we're going to say yes for integer. What about 0.75? Is that an integer? Well, is it a whole number? It's not. It's 75% of something. 0.75 is the same as saying 75%. We're almost there for the whole number. We still have 25% to go, but we're not quite there. So 0.75, no, not a whole number. So not an integer. Let's look at the next one. 1 over 6, 1/6. Is 1/6 of something a whole number? It's not. It's a sixth of something. You need 5 more of them to make up a whole number. So the answer for 1 over 6 or 1/6 is a big no. And what about negative 14? Is that a whole number? Well, it's a negative number, right? So what does that mean? It just means it's a negative whole number. So negative 14, just like 14 on the top, absolutely an integer. How'd you do on that? Okay, this one wasn't too bad. Let's go to the next one. Okay, let's try this. We're going to order these integers from least to greatest. Now be very careful here when you do lessons or tests on this. Sometimes they say from greatest to least. Sometimes they say from least to greatest. We're going to start with the lowest value integer and work our way up to the greatest value integer. So let's start with number one. Number one, we've got the number 3, negative 4, 10, 2, and negative 9. The lowest value integer is the one that places furthest left on the number line. So if we create a number line right here, and we place our 0 right here, we've got 1, 2, 3, 4, 5, 6, 7 here, and 1, 2, 3, 4, 5, 6, 7 here. We can put our numbers in. We've got 1, 2, 3, 4, 5, 6, 7, and negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. When we look at this, on the left here, that's the negative numbers. On the right, we've got our positive numbers. So let's take the first set of numbers. We've got the number 3, which is right here. Then we've got the number negative 4, which is right here. Then we've got the number 10, which would be somewhere over here. Then we've got the number 2, and then we've got the number negative 9, which would be somewhere over here. We've got all 5 numbers circled up there. Now, which number appears furthest to the left, furthest down the negative side of the line? Well, that would be this one right here, negative 9. So negative 9 is the first number in the order. Now we take the next one. Which one is the second furthest to the left? Well, that would be this one right here, negative 4. So now we're at negative 9, negative 4, and we can kind of cross those off as we go. Next, we've got 3, 10, and 2. Well, as we keep going, we've already placed negative 9 as the furthest to the left. We've already placed negative 4 as the second furthest to the left. We keep moving to the right. Which one of those numbers shows up next as we move to the right? Well, that would be the number 2 right here. So put a comma here, and 2 is our next number. And if you keep going, 3 is our next one, and then the last one is 10. And we can kind of cross those off as we're going along. So negative 9, then negative 4, then 2, then 3, then 10. We're just kind of moving along right, in a right direction all the way to the last number. That's how we're doing this. The further away you go from 0 down the left side of the negative line, the smaller the number is, or the lower the value of the number is. Let's try the next one. We've got -8, then we've got 0, then -13, then 6, then -6. Well, let's pick the largest negative number to start this. The largest negative number here is going to be -13. So let's cross that off our list. Now we're left with 4 numbers that are a lot more manageable. Let's pick again the largest negative number that's left. And at this point, the largest negative number that's left is going to be -8. Let's cross that off. Now we're left with 3 numbers. What is the largest negative number left? The largest negative number left here is -6. So let's cross that off our list. Now we've got 0 and 6. There are no more negative numbers, right? So let's just start with the smallest number and work our way up to the bigger one. Between 0 and 6, the next number would be 0. And as we work our way to the right on the number line, we're left with 6. So here we have it, -13, -8, -6, 0, and 6. That would be the correct order for these numbers if you are placing them from least to greatest on a number line. Let's try the last one. On the last one, we've got 5, -15, 7, -5, and -7. Let's start with the largest negative number, and that would be -15. Let's cross it off our list. Now we've got 5, 7, -5, and -7. Well, out of those, the largest negative number when we have negative numbers left is -7. So let's cross that off our list. Now we've got 5, 7, and -5. Well, 2 positive numbers and 1 negative number. Of course, the negative number is a smaller value or a less value than the positive number, so the largest negative number that we have left is going to be -5. So let's cross that off, and now we've got a 5 or a 7. Well, we're going to keep working our way to the right on the number line, so the next one, we've crossed over 0. Now we'd be counting up 1, 2, 3, 4, 5. 5 would be the next number in the order here, and that leaves us with 1 number left, 7. So here we have it on a number line. Here's how this would look. -15, -7, -5, 5, and 7. How'd you do on that one? These can be a little tricky. Let's see how you do in the next part. I'm going to sing a little song for you here. Have you ever heard the song, Row, Row, Row Your Boat? Row, row, row your boat. You know that one. Well, I've got a new song here, and I want you to think about this. We're going to use this song when we're doing addition of integers, just for addition of integers. And here's how the song goes. Same sign, add and keep, different sign, subtract. Keep the sign of the larger number, and then you'll be on track. Do you get how that goes? Same signs, add and keep. Different signs, subtract, and keep the sign of the larger number. That's what we're looking at. And this only applies for addition of integers. It doesn't apply for anything else. So when you're adding integers, when you see this plus sign between 2 integers, you are adding integers. You're finding the sum. And this is the only time that you use this. Let's start from the top. We've got the number 2 and the number -3. Are those the same signs or are those different signs? And the signs are if it's a positive or a negative. Are those the same signs or are those different signs? Well, those are different signs. You have a +2 or a 2 and a -3. So according to the song, different signs subtract and keep the sign of the larger number. So that's what we're going to do. We've got a 3 here and a 2, and we're going to subtract them. If we take 3 and we subtract 2, we're going to wind up with a 1. Now, which one's the bigger number, 3 or 2? Well, 3 is a bigger number. And what sign does 3 have? 3 has a negative. It's a -3. So we're keeping the sign of the larger number, right? So we're keeping the negative. So 2 plus a -3 is -1. That's how you can figure that out. Let's go to the next one. We've got -12 plus -2. We're adding 2 negative numbers. Let's go to the song on the top. Same signs, add and keep. Are they the same signs? Well, you've got a -12 and a -2. They are the same signs. So this one is really simple. We're doing the top line of the song. Same signs, add and keep. We're adding them together. 12 plus 2, which is 14. And since they're both negatives right here, we're keeping the sign. Negative 12 plus negative 2 is negative 14. Okay, let's go to the next one. Looks similar, but it is not the same. Here we've got negative 12, right? Plus 2. Negative 12 plus 2. And it's an addition of integers problem. Let's go to the song. If we go on the song, we see same signs, add and keep. Are they the same signs? A negative 12 and a positive 2. They're not the same signs. They're different. So the next line of the song is different signs subtract, keep the sign of the larger number. So if we go over here, we've got different signs subtract. So we've got our 12 and we're going to minus 2. 12 minus 2 is 10. Now, we're going to keep the sign of the larger number. Well, 12 is a much bigger number than 2, and it has a negative. So we're going to have to keep the negative sign here. So the answer to this, negative 12 plus 2 is negative 10. And then let's go down to the very last one. We've got a negative 1 plus 1. Well, anytime you have a negative and a positive of the same number, it's 0. Right? If you've got one number and you take it away, it's 0. But let's try the song. Are they the same signs, a negative 1 and a positive 1? They're not. So we're going to have to subtract and keep the sign of the larger number. So if we take 1 and we subtract 1, we're going to get 0. And keeping the sign of the larger number in this case doesn't matter because they're both the same number and because 0 isn't positive or negative. It's just 0. So the answer there is 0. How'd you do on these? Remember that song and you should be really good on addition of integers. Let's go to the next page. Now we're looking at subtraction. For subtraction, the rules are different. Remember, the song is just for adding. For subtraction, we have to do something a little different. First of all, it's subtraction if the operation sign is subtraction. In the last page, the operation sign was addition. We did do some subtraction as a little trick, but it was still an addition problem. Here, the operation sign is subtraction, so these are all subtraction problems. Here's the rules for subtraction. First, we're going to change the operation, the subtraction symbol, to addition. After that, we're going to change the sign of the very next number only to the opposite sign. And the reason we're doing that, because when you have an addition problem, you can then sing the song and figure the problem out. Let's look at this example right here, 6 minus 5. Well, right in this example here, we show that we take the 6 minus 5, and if we change the operation sign from subtraction to addition, right, then we have 6 plus 5. But the very next step is, if we do that, we have to change the sign of the next number. So we have to make that plus 5 and negative 5. So now we wind up with 6 plus negative 5, and we also now wind up with an addition problem. And in addition of integers, you can sing the song. And let's sing it for a moment. Same signs, add and keep. Different signs, subtract. All right, do we have the same signs or different signs for addition right here? Well, we've got a positive 6 and a negative 5, so they're different. So we're going to subtract. So 6 minus 5 equal 1. Then we're going to say to ourselves, well, I've got that 1. I need to look at my 6 and my 5. Which one's the larger number? Well, the 6 is. So I'm going to keep the sign of that number. So the answer is just 1. Let me fix that here so you can kind of see it better. You can see how we got that by changing the operation to addition and changing the sign of the next number. Let's look at number 1, 5 minus 10. If we follow the rule, we're going to change the subtraction operation sign, 5 minus 10, to 5 plus 10. And then because we changed that, we're going to change the sign of the next number and make that a negative 10. So now we've got 5 plus negative 10. Now we can do our song. Same signs, add and keep. Are 5 and negative 10 the same signs? They're not, so we can't add and keep them. Different signs, subtract and keep the sign of the larger number. Are they different signs? Well, they are. One's a positive, one's a negative. So we're subtracting 10 minus 5, which is 5, and we're keeping the sign of the larger number. Out of the 10 and the 5, the 10's a bigger number, so we're keeping that sign. So the answer, 5 minus 10, is actually negative 5. Let's go to the next one. 2 minus 6. We're going to do this one over here. 2 minus 6. Well, we're changing that subtraction operation to addition, and we're changing the sign of the next number to negative. Now we've got 2 plus -6, and we can use our little song. Same signs, add and keep, different signs, subtract. Are they the same signs? A 2 and a -6? They're not. So we're going to have to go to different signs, subtract, and keep the sign of the larger number. Well, we've got 6 minus 2, which is 4. And then we're going to keep the sign of the larger number. We've got a 2 and a 6. The larger number is a 6, and it's a negative, right? So we need to keep the sign of the larger number. So the answer to number 2 is -4. Let's go to number 3, and we'll do that right over here, right? -7 minus -8. All right, we want to change this subtraction operation to addition. And then when we do that, we need to change the sign of the next number. This is where it gets a little confusing when you have two negatives, all right? So now we've got -7 plus +8. -7 plus +8. Are they the same signs or are they different? Same signs, add and keep, different signs, subtract. Well, they're different. One's a -7 and one's a +8. Let's fix that 8 so you can kind of see that there, right? Not that that helps in any way, but that's the way it is. All right, so that means we need to subtract. 8 minus 7 is 1. And we're going to keep the sign of the larger number. Well, is 7 a larger number or 8 a larger number? Well, 8 is, and that's a positive. So that answer is +1. And now we've got one more right over here we're going to do. 15 minus -9. When we're doing subtraction of integers, again, the first step is to change that subtraction operation sign to addition. And to change the sign of the very next number. Now we've got 15 plus +9. So 15 plus 9. Same signs, add and keep. Well, the same signs, a +15 plus a +9. They are. So all we're doing is adding 15 plus 9. And we all know that 15 plus 9 is 24. And that's the answer. Does that sound confusing? It can be if you let it, but if you just think about the reason we're doing this, we're changing subtraction to addition and changing the sign of the next number so we can use the song. And the song helps us to figure out the correct answer. All right, let's go to the next page. Let's look at multiplying and dividing integers. To me, multiplying and dividing integers is much simpler. Let me tell you the rules first, and then I'll show you how to do this in a really simple way. The rules are, if you have a positive number and you multiply or divide it by a positive number, you get a positive answer. So for instance, 5 times 5 is 25. They're all positive numbers. 25 divided by 5 is 5. They're all positive numbers. We do that every day. Now, here's the new part. If you have a negative number and you multiply or divide it by a negative number, you get a positive answer. So for instance, if you have -5 times -5, you're going to get +25. That's a new concept, but that's how it works. A negative times a negative is a positive. The same thing with division. If you have a -25 divided by a -5, you're going to get a +5. So in multiplication and division, a negative times or divided by a negative is also a positive answer. The only time it's a negative answer is if it's an odd number of negatives. So if you have one positive number multiplied divided by one negative number, you're going to get a negative answer. So here's the rule that I follow. I do the math, right? The multiplication or division as normal. I count the number of negative numbers. Then I say, hey, if there are odd number of negative numbers in the problem, the answer is negative. If there is an even number of negative numbers in the problem, the answer is positive. That's what I do. I do the math, count the negatives, and if it's an odd number, 1, 3, 5, 7, then it's a negative answer. If it's an even number, 2, 4, 6, 8 negatives, then it's a positive answer. Let's go to the first one. Let's do -10 times 4. Well, I think we all know that 10 times 4 is 40, hopefully. How many negatives do we have in this problem? Well, we have 1 right here. 1 is an odd number. There's an odd number of negatives, so the answer is negative. If you look here, odd number of negatives is a negative answer. Let's go to the next one. -7 times -8. Well, I think we all know that 7 times 8 is 56. How many negatives are there? There's 1, 2. That's an even number of negatives. So if we look over here, even number of negatives is a positive answer. So that answer is just plain old 56. Try the next one. Stop the video if you'd like and see if you can figure out the next two. Okay, 3 times negative 11. If we multiply 11 times 3, we get 33. Now, how many negatives do we have? We have 1 negative. That's it. 1 is an odd number. So if we look at our little chart on the top, if there's an odd number of negatives, it's a negative answer. So the answer to this is negative 33. And let's do the last one. 2 times 12, well, that's 24. And then how many negatives do we have? We've got 2. Well, 2 is an even number. So if we look at our list up there, if there's an even number of negative numbers, the answer is positive. So the answer is positive 24. Division works the same way. 20 divided by 2, well, that's 10. And let's look at how many negatives we have. We have 1 negative. Well, 1 is an odd number. If we look up our chart on the left there, odd number of negatives means a negative answer. So the answer to this is negative 10. Well, let's look at the next one. 81 divided by negative 9. Well, 81 divided by 9 is 9. And then how many negatives do we have? We just have the 1. That's it. So 1 is an odd number. That's a negative answer. Let's look at the next one. 50 divided by 10, well, that's 5, right? Because 5 times 10 is 50. How many negatives do we have? 1, 2, right? 2 negative numbers. Well, if we look at our chart on the left, if there are an even number of negative numbers, then the answer is positive. 2 negatives is an even number of negative numbers, so the answer is just 5. And then if we look at the very last question, negative 12 divided by negative 4. Well, 12 divided by 4 is 3. And how many negatives do we have? 1, 2. We have 2 negative numbers, right? That's an even number of negatives, so the answer is going to be a positive 3. How'd you do on that one? That one could be a little tricky, but to me, it's much easier than addition and subtraction. All right, let's go to the next page. Next, we're going to talk about absolute value. The absolute value of a number is its distance from 0. For instance, let's take the absolute value of negative 4. Absolute value is portrayed by putting a line on either side of the number, just a straight bar. The absolute value of negative 4, let's figure that out. The absolute value is the distance from 0. That's the absolute value of a number. So if we're looking at the absolute value of negative 4, let's start at 0 and find out what the distance is. 1, 2, 3, 4. The absolute value of negative 4 means it's 4 spaces from 0. So what is the absolute value of negative 4? The absolute value of negative 4 is 4 because it's 4 spaces from 0. Let's look at the absolute value of 4. Again, the absolute value of 4 is how many spaces from 0 is this number? Well, it's going in the other direction, but it is 1, 2, 3, 4. A positive 4 is 4 spaces from 0. So the absolute value of 4 is still 4. The absolute value of a number is always positive. So whatever the number is, if it's a negative 4, if it's a 4, if it's a negative 8, or it's an 8, it's always going to be positive. Let's look at the first one and see what we come up with. We've got 3, and we're looking for the absolute value of 3. Well, how many spaces is 3 from 0? It's 1, 2, 3. So the absolute value of 3 is 3. Let's look at number 2. The absolute value of negative 5. Well, how many spaces is negative 5 from 0? Well, it's 1, 2, 3, 4, 5. So the absolute value of negative 5 is 5. Do you see the pattern here? It's whatever the number is inside the absolute value bars without the negative sign. The absolute value is always positive. Stop the video and see if you can do the next two on your own. Okay, what is the absolute value of negative 2? Well, I think we can figure this out. It should be 2. How many spaces is negative 2 from 0? 1, 2. It's 2. And the absolute value of 5? Well, how many spaces is 5 from 0? 1, 2, 3, 4, 5. It's 5. So the absolute value of a number is the spaces from 0. The absolute value of any number, whether it's negative or positive, is just that number, positive. There are no negative absolute values. How'd you do on that? That one's pretty simple. You're going to need it on the next question. Let's see what that's all about. All right, the last question on this review is going to be a number line word problem. Don't you just love these number line word problems? I know, me either. On Saturday at noon, the temperature was 12 degrees Fahrenheit. By 8 p.m., the temperature was negative 17 degrees Fahrenheit. On Sunday at noon, the temperature was 25 degrees Fahrenheit. By 10 p.m., the temperature was negative 6 degrees Fahrenheit. On which day did the greatest change in temperature happen? All right, this is a number line word problem. And on these, when they do these temperature problems, the temperatures are really tricky because you can't just subtract the numbers from each other. That doesn't work. What you have to do is figure out their distance from zero when it's a temperature problem, because temperature is all based upon whether you're above zero or below zero. And the easiest way to do that on your test is to take the absolute values of each number and add them. So let's start with Saturday. On Saturday, the temperature was 12 degrees Fahrenheit. Let's do the absolute value of 12, all right? Remember, for absolute value, put those bars. By 8 p.m., the temperature was negative 17 F. So we're going to add the absolute value of negative 17. So this problem is going to be the absolute value of 12 plus the absolute value of negative 17. This gives us the distance from zero in each direction for those temperatures. So if we take the absolute value of 12, which is 12, plus the absolute value of negative 17, which is 17, we're going to get 29. Now let's do the second day. On the second day, on Sunday, the temperature was 25 degrees Fahrenheit. So let's take the absolute value of 25, all right? And add it to, by 10 p.m., the temperature was negative 6 degrees Fahrenheit. And add it to the absolute value of negative 6, all right? Well, we know that the absolute value of 25 is 25. If we add it to the absolute value of negative 6, the absolute value of negative 6 is 6, right? And that's going to be 31. So on Saturday, the temperature difference, the difference in temperature was 29 degrees. On Sunday, the difference in temperature was 31 degrees. On which day did the greatest temperature change happen? Well, on Saturday, we had 29 degrees of a difference. On Sunday, we had 31 degrees of difference. The answer is Sunday by 2 degrees. How'd you do on that one? All right, that one wasn't too bad. All right, that's our video for today.
Please hit that like button and don't forget to subscribe or I'm giving you detention. There's the bell. We'll see you next time.